Preparation of alcohols. Now we can prepare alcohols by many methods, like the first one in the list is from alkenes. From alkenes they can be prepared by acid catalyzed hydration. Let me give an example. If we have this propene, to which when water is added in presence of sulfuric acid, what happens is isopropyl alcohol is formed. It's an addition reaction, definitely an electrophilic addition reaction, in which the water is added as per Markovnikov's rule. The OH, the negative part, is going to the more substituted carbon. Let us see the mechanism of this reaction, which says first the sulfuric acid breaks down into H plus and the HSO4 minus ion. This is how we get electrophile. Now this electrophile attacks on this unsymmetrical alkene. The shifting of the double bond takes place, and the hydrogen H plus ions proton attack in this way. The more stable carbocation, which is the secondary carbocation in this case, is formed. Now as soon as the secondary carbocation is formed, what happens is water as a nucleophile attacks on this carbon, and what we get is this oxonium ion. Now oxygen is having only one lone pair left out now, so it withdraws its one pair which this is sharing with the hydrogen, so that the H plus is given out. So what we get at the end in this case is let me write it down like this, the fourth step, which is basically is from this, or we can write it here. So this H comes out, so it's minus H plus, so whatever the H we have got is again is regenerated back, is given out back, and what we get is at the end is CH3, CH, CH3, OH. So this is what we have, the preparation of isopropyl alcohol, in which what happens is the electrophilic addition of the water molecule takes place, and the OH is actually the final product is as per the Markovnikov's rule. We can also prepare alcohols from alkenes only by another reaction which is called hydroboration oxidation. Now what we do in this case is, let us take the example of this propene again. This propene is reacted with B2H6, which is called diborane. We know that diborane is a dimer of BH3, the boron hydride. It's an electron deficient Lewis acid species, and therefore what happens is it works as an electrophile. Now what happens in this case is, when alkene is added or reacted with diborane, trialkyl borane is formed. Like what happens is, one of the hydrogens from here will come out and will attack on this this carbon as a hydride on the more substituted carbon, and the product obtained therefore will be somehow like this. So all hydrogens in this way get substituted, and we get what? Tripropyl borane. Now this tripropyl borane is then reacted with hydrogen peroxide in presence of basic medium. It breaks like this, OH and OH. So what we get is CH3, CH2, CH2OH plus of course boric acid. This is the boric acid. Now the alcohol obtained is propane 1-ol. the OH group is attached to the first carbon atom, and on seeing the final product, we think that we can clearly think about this, that the addition of the water molecule has taken place in such a way that the OH or negative part is going to a lesser substituted carbon atom. So the addition is following an anti-Markovnikov's rule, but it's not correct, because the addition of initial B2H6 on this alkene has already taken place as per the Markovnikov's rule, and the hydrogen peroxide, since the last carbon was attached to the boron, due to the addition of hydrogen peroxide, the OH therefore gets attached to the first carbon only, and that is why the product obtained is propane 1-ol. So this is what we have, the basic reaction: hydroboration, oxidation. Why it is very important? The reason being because the addition of the water looks like to be according to the anti-Markovnikov's rule. The product appears to be an anti-Markovnikov's product. The OH group goes to the lesser substituted carbon atom, but actually it is not happening like this.